We added some new features, and we're going to be highlighting some of these throughout our demonstration. One of them is diffuse scattering. This captures clutter from rough surfaces on roads, walls, and other structures. We have multiple models that are tunable, as we'll describe a little later. And one of the things that's critical to be able to use the diffuse scattering with the Doppler calculation is that we've spent quite a bit of time developing and implementing these methods with some extensions that allow us to retain relative phases between pulses. So when we're dealing with a diffuse scattering calculation, the phase, it's not possible to know the phase because we're interacting with things that are much smaller than a wavelength in these models. So the phase is randomized, but the integration points and the initial phases are retained between the pulses. So we are able to capture how those phases may shift relatively as things are moving over very small distances, such as the frame for a sequence of chirps. And this allows us to capture a Doppler from the scattering. The scattering aggregates paths over each facet. So we have the option to break up something like this asphalt into lots of small facets so that we can capture individual ray paths. And in this view, we can see a lot of small ray paths here that are going out to the asphalt that are due to diffuse scattering, and that's being added in with some of the more specular scattering returns that we get from the car, the guardrails, and the sign. Overall, what we tend to see is our complex impulse response shown in blue. When we add in diffuse scattering, we see a great deal of additional clutter, particularly at closer ranges where the power is strong. And this adds more of the interactions that we're going to see as we're driving in an open roadway scene.